we're going to begin talking about standard costing, and let's start understanding the difference between what's a standard cost and what budgets are. Both standard costing and budgets are predetermined costs that help us plan and control. So standard costs are basically going to help management control based on unit amounts. Budgets help us with the huge picture, right? The huge picture of planned production, planned sales, activities. But these standard costs relate to unit prices, what we plan the costing to be per unit, per item. Why do we have these standard costs? It helps management plan. It makes us cost conscious. It makes us understand how much we need to sell the product for. And it helps us see variances. We've started kind of talking about some variances in the previous chapter. Setting standard costs requires input from all those individuals that have responsibility for adhering to certain costs. Standards should change whenever managers determine that the existing standards are not good measures of performance. So we're going to have standards as it relates to costs, and we're going to have standards as it relates to quantities. Standards for both. There are ideal standards like 100% efficiency, 100% capacity, but then there's realistic standards. So ideal standards represent optimum levels of performance under precise, perfect operating conditions. But normal standards are really what we're looking at. Those are efficiency levels that really are more attainable under good situations, good operating conditions. Properly set, normal standards should be tough, but they should not be unattainable. Nothing is worse than someone tries to create standards you know you will never attain. What's going to happen? You're failing to begin with, right? It's a lose-lose. Most companies that use standards set them at, is it an optimum level, an ideal level, a normal level, or practical level? A normal level is what they should set them at. So to establish the standard cost of producing a product, it's necessary to establish standards for manufacturing costs as they relate to direct materials, direct labor, and manufacturing overhead. So the standard gets implemented by coming up with a price to be paid and how much needs to be used for each product. As it relates to direct materials, this standard price is the cost per unit of direct materials. So we should have here the purchase price of the material, whatever other expenses are incurred to get the product here. So this price per pound, or $3 per pound, we set as the benchmark of what we should be paying for material. The direct material quantity, okay, so not the price now, but the quantity is the quantity of materials that should be used per unit of finished goods. So with one item, we need 4 direct material quantity. So we need 4 pounds per item. This gives us how much we need. Why do we care about this? Why would we go over and have 5 pounds or 6 pounds? Why might that happen? We're not being careful with our cutting if we're dealing with, items. We might not be running our equipment safely, or we're abusing it, and as a result we have shutdowns. These quantity dollars are helping for efficiency purposes. Are we utilizing the materials to the best we can? Okay? In this scenario, the standard direct materials cost is going to be the 4 pounds times what we originally showed the price per pound to be, $3. So the material cost would be $12 based on both of those standards. The direct materials price standard should include an amount for all the following except A, receiving costs, storing costs, handling cost, or normal spoilage costs. What do you think? Anyone? Normal spoilage cost is not included in these standard costs. The direct labor price standard is the rate per hour that should be incurred for labor. So we've got our hourly rate, our various taxes. So we have this labor rate per hour of $15. And then the time used to make 1 unit of product should be calculated. So here you can see we should have prep time, production time, downtime of about 2 hours per unit. And so in that case, we know our standard direct labor cost is going to be 2 hours times $10 an hour, or $20. Manufacturing overhead generally comes out with a standard predetermined overhead rate. Basically, we take this by dividing budgeted overhead costs by some standard activity index to come up with our standard cost of overhead. So as you can see here, we'll come up with a standard cost per gallon is $52. The standard cost per unit is the sum of all the standard cost of direct materials, direct labor, manufacturing overhead. So we've got this exonic tonic. Ooh, I wonder what's in this. We could dream what it could be. But we've got here our materials, our labor, and our overhead. Why would our labor be so high for an exonic tonic? I don't get that. But whatever, our standard cost here is $52. Let's talk about an example. Radet accumulated the following standard cost data concerning product CTY31. Materials per unit of 1.5 pounds at $4 a pound, labor of 0.25 hours at $13 an hour, and manufacturing overhead is 120% of direct labor cost. Compute the standard cost of 1 unit of CTY31. So we're given our materials, we're given our labor. It tells us our predetermined overhead rate is going to be 120% of direct labor cost. If our direct labor cost is $325, wouldn't that make 120% of $325 to be $390? So we've got our total standard cost of $13.15 per this product. Now we've got variances. We kind of talked about variances the other day, but variances are the difference between what we actually have costs of and what the standard costs are supposed to be. So if our actual costs are less than standard costs, that's a good sign. It's a positive variance or favorable. If our actual costs are going to be greater than our standard costs, then that's going to be an unfavorable variance. They need to be analyzed to see why. Maybe our standards are unacceptable. Maybe they're out of date. Maybe there's a reason behind it. We need to find out why. You analyze those variances to see why. A variance is favorable if actual costs are less than budgeted, less than standard, greater than budgeted, or greater than standard. What is it? Less than standard. Let's look here. Assume that in producing 1,000 gallons of exonic tonic in the month of June, Exonic incurred the costs to the right, $55,000. The total standard cost of Exonic is $52,000. So look at our variance, guys. We have an unfavorable variance of $3,000. That says our actual costs are greater than our standard costs. In completing the order for 1,000 gallons of Exonic tonic, Exonic used 4,200 pounds of direct materials. These were purchased at a cost of $3.10 per unit, but the standard price is $3 a unit. So do you see here that our direct material variance is going to be the actual quantity times the actual price. Actual quantity times, this should be the actual quantity times, see that this is goofy, actual quantity times standard price. This should be actual quantity times standard price, and standard quantity times standard price. This will give us our materials variance. So as you can see here, no, they're doing actual price. So our actual quantity of 4,200 times our actual price of $3.10 versus our standard quantity times our standard price gives us our material variance unfavorable. So the company analyzes the total variance to determine the amounts that are related to price and the amounts related to use. So the price variance is going to be the actual quantity times the actual price minus the actual quantity times the standard price. So in looking at this, we see that the price is unfavorable at 420. See how we break down how much is the price and how much is the quantity. Then when we deal with the quantity variance, we're going to do actual quantity times the standard price minus the standard quantity times the standard price to see the quantity difference. So we've got price difference and quantity difference that make up the total variance. Okay? So when we're dealing with actual quantity and actual price, that's what we really completed. Okay? Then that is part of this price variance. Do you see the number 2, actual quantity times the standard price? When we take AQ times AP and we subtract it times AQ times standard price, this gives us our price variance. When we look at the quantity variance, do you see how we take our actual quantity times our standard price and we subtract from that our standard quantity times our standard price to get our quantity variance? And then both of them together, the price and the quantity, give us our total variance. Do you see how these numbers play out? Know this. This is an important piece to know how you calculate the figures here. Why would material variance be altered? Factors affect the price paid for raw materials, including availability of quantity, cash discounts, the quality of the materials, the delivery method. All of these factors need to be put into thought in setting the price standard. The material quantity variance, if the variance is due to inexperienced workers, faulty machinery, or carelessness, then that's a problem, right? They're using too much of them. They're being wasteful in their products. Let's look at one. The standard cost of Wonder Walkers includes 2 units of direct materials at $8 per unit. During July, the company buys 22,000 units of direct materials at $7.50 and uses those materials to produce 10,000 units. Compute the total price and quantity variance for materials. So our standard quantity is going to be 10,000 units times 2. 2 units of direct materials and $8 per unit during the company buys 22,000 units and uses those to produce 10,000 units. So our standard quantity is 10,000 units times 2. The total material variance is going to be our 22,000 units times an actual price of $7.50 minus what we should be using is 20,000 units times the standard price of $8 a unit. So we've got an unfavorable variance here of 5,000. But our price variance is going to be favorable, and our materials quantity variance is our unfavorable. Do you see how they're broken down? The total and then the price and the materials variances? Thank you. Absolutely.
How does the unfavorable and favorable get two different answers when it's the exact same equation? Or does it type of?
Okay, this is 11,000 favorable.
Yeah.
This is
Look
60.
at the equations, though. They're exactly the same.
22 times 8 minus 20 times 8.
No, the top two. The total material and the material price variance.
This is 22,000 times 750
Got you.
minus 20,000 times 8. And the materials we're dealing with actual to actual minus standard to standard. In the price we're dealing with actual times actual minus actual times standard. And then the material quantities actual times standard minus standard times standard. So it's important to know what we use to come up with those variances. Now, we have the same thing with direct labor variances. Hey, let's take a break and let's work on a problem like this, okay? Always helps to work on one, right? So, let's go and look at, what page do we need? Five 28, okay? Is that okay, 528? Shannon Company is planning to produce 2,000 units of product in 2014. Each unit requires 3 pounds of material at $5 per pound and a half hour of labor at $15 per hour. The overhead rate is 70% of direct labor. We're going to compute the budgeted amounts for 2014 for direct materials, direct labor, and applied overhead. Okay? So if we go in here for, yes?
So I'm still stuck on that do it problem. So the materials price variance, it is different. I think it's wrong on the slide, but it's the 22 times 8, and the answer is 11,000 favorable, but it's a negative number. So is
Okay.
that just absolute value, or why?
Okay, let me look and see what we're talking about. This do it?
Yeah.
Okay, so we've got the standard quantity here. I don't want to.
10,000 times 2.
1 second. The standard, why can't I, from current slide. So the 10,000 times 2 is the standard quantity. They want 10,000 units and it needs 2 units. The direct materials variance is going to be actual times actual minus standard times standard. So the direct materials is going to be actual times actual minus standard times standard, okay? The material price is going to be actual times actual minus actual times standard. This is the price.
Okay, but then my question for that one is you get a negative 11,000. So why is that favorable, but the positive 5,000 is unfavorable?
Okay, good question. What's 22,000 times 750?
165.
What's 22,000 times 8?
176.
You see how that's a minus? Favorable? Okay, think of this. The actual price we really bought it for is less than what the standard price is. We really bought it for $750, but the standard price is 8. So we got it cheaper. So isn't it always better to get it cheaper than what we planned on getting it for? So you see how that's favorable?
Yeah, we're good now.
Okay, it's okay. We're dealing with so many things. Okay, so let's pull up this exercise here, 11.1, and what we need to do is calculate it asks us here to compute the budgeted amounts for 2014 for direct materials to be used, direct labor, and applied overhead. Nothing to do with actual here, what we're budgeting. We're planning to produce 2,000 units of product. It requires 3 pounds of materials at $5 and a half an hour of labor at $15 and overhead of 70%. So how we will calculate this, direct materials, 2,000 units times 3 times 5 gives us a budgeted amount of materials of 30,000. Our direct labor, 2,000 times a half an hour times $15 an hour will provide us with a standard here of 15,000. And the overhead, 15,000 at 70% is 10,500. So here's what we're budgeting for our direct materials, our direct labor, and our overhead here. Okay? Now the next part says to us, compute the standard cost of 1 unit of product. We got to come up with the standard cost just for 1 unit of product. So we've got 3 units times $5 a unit to just give us $15 as our standard per unit. Our direct labor hours per unit, we only need a half an hour times $15 is $7.50. And our overhead is going to be 70% of our direct labor, or $7.50 times 70% is our $5.25. So our standard cost per unit is going to be $27.75. We're breaking it down per unit. Does that make sense? Okay? Now, next. Hank Itzik manufactures and sells homemade wine, and he wants to develop a standard cost per gallon. The following are required for production of a 50-gallon batch. For a 50-gallon batch, 3,000 ounces of grape concentrate at 6 cents per ounce, and 54 pounds of granulated sugar at 30 cents per pound. Okay? We've got 60 lemons at 60 cents each, 50 yeast tablets at 25 cents each, 50 nutrient tablets. Why would you put nutrients in wine? At 20 cents each, and 2,600 ounces of water at 0.005 cents per ounce. Hank estimates that 4% of the grape concentrate is wasted, 10% of the sugar's lost, and 25% of the lemons cannot be used. We have to compute the standard cost of the ingredients for 1 gallon of wine. How are we going to start doing this, guys? It's confusing? What? We got to figure out the cost. So look what we're going to do. We're going to start. We need per gallon 60 ounces. Okay? Now, the standard waste we're planning on is 4%. So that means we're going to really use 62.5 ounces at 6 cents an ounce to give us our cost per gallon. Now with the sugar, it thinks we have waste in sugar. So it tells us we need 1.08 pounds, but with a waste of 10%, we're expecting to use 1.2 pounds. Or if we take that 1.2 pounds times 30 cents, that gives us our cost per gallon of 36 cents. Now our lemons, we don't think we can use all those lemons, right? So we need 1.2 per gallon. We have a waste of 25%, so really we're at 1.6 per gallon. At 60 cents gives us 96 cents per gallon. We've got our yeast, our nutrients, and our water. So based on the cost per gallon, we're going to be using a standard cost rate per gallon of $5.78 per gallon. Do you see how in our standard cost we're taking our waste? We're taking into account waste. Tell me when I can move on there. Okay. Does this help going over problems, guys? Next. Kim Company has gathered some information. We know the direct materials. Each unit contains 4.5 pounds of material, and there's all this waste and spoilage per unit produced under normal conditions of 0.5 pounds. The material cost is $5 per pound, but Kim always takes the 2% cash discount all of its suppliers offers. Freight cost averaged 25 cents per pound. Now, direct labor, we've got 2 hours of labor. The setup, cleanup, and downtime is 0.3 hours. The average hourly pay rate is $12. Payroll and fringes are $3 more. And then we apply manufacturing overhead at a rate of $7 per direct labor hour. So we've got to come up with our standard cost here. Okay? How are we going to start with the direct materials? What are we going to use to come up with our standard for materials? Somebody? Anybody? Correct. Pound, the cost per pound, okay? And we're going to, for the direct materials, take our discount, okay? And we're going to add our 25 cents. Now, we know that our cost per pound is $5.15. Our pounds per unit, we're taking that, what we know is going to happen, at 5. So our direct materials are at $25.75. Okay? Now next, our direct labor, we've got to add our cost plus the fringe benefits, and then we need to add how many hours it takes per unit times our setup. So $15 times 2.3 gives us our hourly direct hour standard. And then our overhead is going to be based on 2.3 hours at $7 an hour is our manufacturing overhead, to come up with a standard cost of $76.35, isn't it? Got it, guys? How you doing? Any questions on this? Any questions?
I think that's a no.
You know, I'm so glad I have you to help interpret for me, because sometimes I'm just waiting.
I got you.
You got my back. Okay, next. $11.5. The standard cost of product B manufactured by MIT Company includes 3 units of direct materials at $5 a unit. During June, 29,000 units of direct materials are purchased at a cost of $4.70 per unit. And 29,000 units of direct materials are used to produce 9,500 units of B. So we've got the standard cost of B are 3 units at $5 a unit. Okay, those are standard, 3 at 5. During June, 29,000 units of direct materials are purchased at a cost of $4.70 per unit, and 29,000 units of direct materials are used to produce 9,500 units. So you see how we're going to do a standard variance related to quantity and price? Compute the total material variance, the price and quantity variances. How are we going to do that? We're going to start with actual times actual minus standard times standard. That's the total big variance. Actual quantity times actual price is 136,300. But our standard quantity times our standard price was 142. So we are favorable here, 6,200, aren't we? And we came up with our standard quantity at how many units, how many materials to produce a unit, and we produced 9,500 units. Next, to come up with our material price variance, we're going to show actual times actual minus actual quantity times standard price. So actual of 136 minus our actual quantity times our standard price is at 145,000. So we were definitely in a favorable situation. We bought the product cheaper. But look at what's happening to our material quantity. We're taking in here actual quantity times standard price minus standard quantity times standard price. We used more here, didn't we, than we anticipated. So, let's go back here and look. Do you want me to take a minute? Okay, you just let me know when we're done. Do you guys know the guy who just left? He told me that he was going to leave. Can you write his name on here, please? Just because he told me he was going to leave and I don't want to mark him absent. Thank you. Do you want me to move it down? Guys, is this weather not so exciting? It's hard to want to be inside, isn't it? Oh. Okay, can I go on? I thought I put that thing in here. Did I put in here? Ready to move on? You guys gonna let me know? Okay, let me go now. Repeat, assuming the purchase price is $515 and the quantity purchased and used is 28,000 units. So now what we're doing is we're changing the actual, aren't we? So if we change the actual, now it's at $5.50, the actual $5.15, and our actual quantity is at 28,000, not what we had at 29. Then do you see we have a favorable material variance and we have an unfavorable price variance there? Does that make sense? The key to this chapter is understanding when you use actual, when you use standard. When you're dealing with price, you're going to use actual times actual minus actual times standard. When you're dealing with materials, you're going to use actual times standard minus standard times standard, okay? Because you want to compare apples to apples. How are you guys doing? Okay, let's move on and let's take the same thing's going to happen with our direct labor variances. We have our actual hours times our actual rates. Then we'll have our standard hours times our standard rates to come up with our total labor variance. And from there, we can take, to determine our price variance, it's going to be actual times actual minus actual times standard. And from there, our quantity variances is going to be actual times standard minus standard times standard to see how much is related to price and how much is related to quantity. Again, you can see here the total variance is actual to actual minus standard to standard. But computed in there have a price component and a quantity component. Why would labor vary? Well, it might be different paid wages we're paying than expected. Overtime could come into play because we've got other things going on. Or we're allocating workers incorrectly. The manager who authorizes wage increases gets responsible for those higher wages. The production department generally is responsible for labor price variances resulting from misallocation of workers. And when we're dealing with quantity variances, That relates to how well they're working. Are they being efficient or are they sleeping on the job? So manufacturing overhead variances involve total overhead variances, overhead controllable variances, and volume variances. So when we're dealing with manufacturing overhead variances, it's going to be the difference between actual overhead cost and overhead applied to the work done. So it's our variable overhead and our fixed overhead gives us our actual overhead. We've got this predetermined rate of $5 for predetermined overhead costs. So we take our actual overhead and we come up with our overhead that's been applied to come up with our variance. Again, actual times actual minus standard times standard. The standard hours allowed are the hours that should have been worked for the units produced, not that are actually worked, but should have been worked. The overhead variance is analyzed through price variance and through quantity variance, just like we're doing. We've got two various components, quantity and price, in determining the whole overhead variance. Why would manufacturing variances be different than the standard? Overspending or underspending, maintenance on the machines is poor, or we maybe just don't have the business that we would have desired to have. So let's look at this problem, guys. The standard cost of product YY includes 3 hours of direct labor at $12 an hour. The predetermined overhead rate is $20 per direct labor hour. During July, the company incurred 3,500 hours of direct labor at an average rate of $12.40 and $71,003 of manufacturing overhead cost. It produced 1,200 units, so we need to figure out the total, the price and quantity variances, and the overhead variance. So we've got here total labor variances, 3,500 direct labor hours. This is actual times actual, right? Actual hours, actual labor, minus our standard hours times our standard labor. We anticipated to have 3,600 hours at the standard cost, gives us an unfavorable variance. Now, as we deal with the price, it's actual times actual minus actual times standard. And when we deal with the labor quantity, it's going to be actual times standard minus standard times standard, gives us a favorable quantity, so in terms of hours worked. The price is unfavorable, but the quantity of hours is favorable. Do you see how overall there, the total overhead variance is 71,300, which is the 71,300 actual cost, and our standard overhead variance was 3,600 hours is what we anticipated we needed, times our standard of $20 overhead rate per hour. Okay? Does that make sense, guys?
Where's the 36 coming from?
I'm sorry, the 3,600?
Yeah.
3 direct labor hours are what we need, okay? And it's producing 1,200 units. So 3,600 at $20 per direct labor hour. Okay, should we go through a problem? You want to call it a day? You want to go through a problem? We will pick up with the balance scorecard on Tuesday.